Hello, very good day. My name's Callum from DX Commander. Now, I've got a big field and I've always wanted to put up a number of different verticals so I could A-B test how they perform. I've got a real problem with that. So what we're going to do is I'm going to show you a piece of software called MMANA. I've used this before on the channel, so stick around and see how we get on here. I've done a number of tutorials on MMANA if you would like to see what it is, but what I've got in stock already is an antenna I've already drawn, got all the maths for. It's called my DXC all-band vertical, and here it is here. But effectively, it's a lot of different components, culminating in 6 elements that rise up from the surface of the driven plate to give us a number of different frequencies, because RF is a little bit like a piano in that the short notes, the short strings play the high notes and the long strings play the low notes. That's exactly what this is doing. So if we have a look and just calculate here, I don't want this at 3.7, I want to, let's say, 40 meter band. I want to have a look at the far field plot. It's very simple. I calculate this, go to the far field plot, and on the left here is what we call the far field plot plan view. And on the right is the far field plot, what they call the elevation view. So in other words, on the left-hand side, we're flying over the top of the antenna, and there'll be a tiny hole going right the way down to the element. And you can see that hole on the right-hand side. It's in the middle. Okay, so this is a knife through the elevation. Right, now we've seen that, we can add our random, let's buy a step IR because we want to test our step IR against the DX Commander. So we'll plug one in here. I'm going to be putting some numbers in here, but fundamentally Z is the height of this antenna. So we're going to tune it for 40 meters. That'll be 10.4 meters high. And let's randomly put it quite far away, a whole half a wavelength, 60 feet or 20 meters. So if I click this button here, view, you can see now we've put this one quite far away. And it doesn't matter, by the way, how far away this is. It will actually interact. Now, before we hit the calculate button, there's something really important to say, because observant viewers will notice that on my Z at the base of the antenna at the moment is sitting on the ground like a real antenna. But wait, I hear you say, if I disconnect it with my AB switch and ground it, it won't possibly not be sitting on the ground. Or in fact, what happens if I go out to the antenna and physically disconnect the coax? So it's impossible that the driven element is now connected to ground. Unfortunately, you're wrong. Rowley did an experiment when he was using a reflector, a 40-meter reflector, which is about 5% longer than the driven element. And he noticed something really strange. He noticed that without any radials at all on the reflector, and in fact sitting on the ground, off the ground, a bit on it, a bit off it, it didn't really matter. He was getting identical results. And that's because what we discovered is that he'd carpeted the ground with his ground, copper wire, and just like a mag mount on a VHF antenna works on your car roof, this is what was happening here. So unfortunately, we can't unground our element from the ground. It exists. Bear that in mind. And we can do some experiments like that later in the year if you're after. So what have we got? Well, we've now got a completely strange shape. We've got over here minus 1.2 and over here 4.5. So we're about an S point difference, depending on where our signal is coming from. Now, if you've just got general noise floor and that's all you're after, you probably never notice a difference. But if you had a very specific noise coming from your neighbour up the road on their fairy lights, on one antenna it might be picking those up extremely well, and the other antenna it might not be picking them up at all. And you will think that one antenna is doing better than the other. By the way, I could move this thing around. I could go from 20 meters to 10 meters to 7 meters. It doesn't matter how far you move it around. You will always get this interaction. There it is. Now it's starting to behave a bit more like a traditional reflector, and we're getting this lobe coming out the front. What happens if we move it even closer? So only 7 meters away or 24 feet, something like that. Because that's not a traditional, it's quite close together. Is that going to do any better? No, it isn't. What happens if we go a whole wavelength? Man, the other side of the property, miles away, 40 meters, 120, 130 feet or something. 40 meters away, miles away. You would, clearly they're not going to see each other now, or are they? Oops, I didn't hit the start button. No, we're still getting a pattern. So you would have to be a long way away, particularly on a resonant frequency. A/B testing is a nightmare. The best way out of this problem is to, on one day, run one antenna, ideally on Whisper, WSPR. And I did a video about Whisper, and I'll put a link to that in the description and in a card up here if you're watching on YouTube. And then the next day, swap over and do the next one. All right, it's the only super reliable way of getting 2 days worth of data on multiple frequencies, and also day and night. Because, for instance, 40 meters daytime is going to have a completely different feel to 40 meters nighttime, particularly on a vertical. At nighttime on 40 meters, for instance, the angle of attack, the angle that's coming, your signals are coming in and going out, much more effective, low down. All right, so from Callum here in the bunker, have a jolly good day. Trust this has enlightened you and given you some entertainment here on YouTube. See you next time. Bye for now.